All right, hello everyone. I'm Nikolai Kondrashov. I work at Red Hat on the CKI project where we do both internal and upstream kernel testing and CI. I'm also working with KernelCI as a KCI-DB maintainer, and KCI-DB is what this presentation is going to be about. I also maintain Digiment project where I do drivers for graphics tablets in my free time, and in the rest of my free time I play with electronics and embedded. I'm from Russia originally, and I'm living in Finland right now. So if you manage to get a hold of these slides, I wasn't able to share a link yet. There are links at the bottom of some slides, which could be quite useful. You can click them. So as you know, there is a lot of testing NCI systems trying to test kernel and doing quite a good job. But they all have their own separate dashboards, and they all send their own separate report emails at various points in the development cycle, whenever it works for them and for developers. And that's kind of, I would say, not very convenient to developers, and requires a lot of time and attention to get adjusted to all the different ways and to wade through all the emails. So after Linux Plumbers in 2019, CKI and Red Hat organized a little get-together for 2 days, and a bunch of people from various companies showed up, and we discussed all the possible ways we can improve kernel testing and CI. And one of the things was a decision to try to unify our pipelines, our testing approaches at the place where it will be the easiest, basically the end of the pipelines where we are about to send emails. The objective being to just have one dashboard, send one email for all those results, and to save developer time and to improve engagement and get better results with the testing. So at that moment, the KCI-DB project was born. And our main idea was from the start to make it as easy as possible to submit data and to get the data sooner and as early as possible from as many CI systems and testing systems as possible, then look for patterns that arise through there, put them into the schema and into the code, and then start another cycle getting new data. That's what we've been doing so far, and I'll leave you to decide how it works. So many will probably remember the XKCD comment about the standards where you cannot just standardize everything, you just end up adding another standard. That's quite true, and but in this case, there are basically no standards so far for unifying kernel test reporting, because all the test reporting systems are working for just one system mostly. There is KernelCI as it is right now, but it is just doing reporting. The reporting part is doing just reporting for the KernelCI. So let's hope that it's going to be first. Okay, so the bigger picture of KernelCI is with relation to KCI-DB is this, that there is the native tests and the Lava labs and all the labs throughout the world doing the testing for KernelCI and using the protocol for reporting and for receiving test jobs. And there are custom labs on the horizon and also the static checks. And there is also the KCI-DB protocol, which KernelCI accepts, and the database and the dashboard and the whole system that takes that data, and it receives the data from the KernelCI backend as it is. So all the KernelCI testing results go in there, as well as so far 5 other systems, including Linaro Tux Suite and all the others that you can see on the slide. And a bunch of other systems are in various stages of working or talking about working on this. So if you look a little closer, the KCI-DB architecture is very simple. Basically, all the submitters just generate JSON objects and send them to a message queue, which gets submitted to the database then, and you can use the dashboard to view those results. There's also a subscription system which looks at what data is coming in and sends out notifications on test results. So we have command line tools for managing all this and for submission and querying. We have Python library for submission and querying, and we have the dashboard. That's how it looks right now. It's built with Grafana, very basic. We're working on making it better. We also have proof of concept reports sent to a development mail list where you can take a look at them. Again, they link at the bottom of the slide. You can click it and see those. We have an alternative implementation of the protocol and the schema and the whole system being developed at KernelCI for internal result handling, and that's work in progress, but we are pretty far there, and some parts of the system are using the KCI ADB protocol already. And this is a dashboard that utilizes it. So the schema itself is very basic. It's just a JSON object with 3 arrays, one for revision information, one for build information, one for test information. And when you submit data, you don't have to, specify a particular combination or anything. You can start with just submitting the revision information and the build information, and later submit another revision and 2 builds, one for this, one for other revision, and some tests, and later come in and do more tests. Or you can go the other way around, just in reverse order. The data will only be considered once it's complete. Well, of course, like once the structure is complete, but the tests, for example, will appear gradually in the results. It's just that the test has to have a build and the revision before appearing somewhere. Okay, so internally we have ID fields, of course, for each of those objects, and those are generated by the submitter, and the submitter is responsible for ensuring that they are unique. And these IDs are used to refer to the object, so you don't have to come into the database and ask for an ID and then use it to refer to the object. And there's no back and forth. You just submit the data and you go. Another field is you obviously have to sign it, say where it's coming from, and that's all the fields that are required for a submission to succeed. This is the data that will already be accepted into the database. It's not much use, but it makes you free to choose how you want to proceed further, and that's a big part of how we try to make it easy to submit data there to the KCI ADB database. Later, once you start building up your involvement with the system and your contributions, you can start adding various fields for various objects and fill it up with the data to make it more useful for developers and the system. There is also a field for putting whatever data you want into your objects. Every object has a misc field where you can put, for example, data for debugging your submissions, or the data that you want developers to have before it is formalized, before it is in the schema, before it has a special field like some extra data about your tests or build or whatever. And this also allows us, the KernelCI ADB developers, to see what kind of data you have and decide how to formalize and how to put it into use properly. You can see all the details about the current schema in production at this link. Further on, our main database right now is Google BigQuery, and the schema is described in Python. We use one data set per schema, per the submission schema, and that's our way to upgrade the database right now for the start. And I'm telling you this, and also the name of the current database, KernelCI 04, because this data set is actually open and you can access it using BigQuery command line tools or the console. For example, this link down here will lead you to the console where you can press run and query the schema of the database again, or you can use this query and see the number of revision objects per Git repository or number of builds per per architecture or number of runs per specific test that we have in the database. You can also use tools like Google Data Studio to make graphs or reports with that data freely. You don't have to have any particular credentials, just some Google credentials. Here are some examples of how data looks coming from our original dashboard and from the source to the KCI ADB dashboard. So, for example, here is the revision in the Linux tree, then the same revision in the native KernelCI testing system, and the same revision in the CKI system. And here's an example of CKI data representing that revision as submitted to KCI ADB. And here's how it could look in the dashboard. And you can also see that there are, for example, Red Hat builds on the same page and the KernelCI builds. There is another example is a build in KernelCI native again, then the JSON data, and then the dashboard, and a test example from KernelCI native, which is well, some login test, and here's the JSON data and the dashboard again for it, and it's the same for CKI, the data warehouse, and the JSON and the dashboard in KCI ADB. So for correlation, we have several approaches. First is that we identify revisions using commit hash or commit hash plus patch set hash, which is generated rather simply, but it's good enough for the start and it's easy to implement. There is an example in Shell how you can generate a hash for a patch set and Python. We use the commit hash and the patch set hash to identify a particular revision and correlate results coming from different CI systems. We also maintain a proof of concept or like a preliminary test catalog where we try to organize the tests by name so that all the CI systems use the same name and we can correlate results. There's an example of K-solve test, and we just take a name of the test suite and homepage so we can identify them. This name appears in the data that you send. You have to set it there, and also appears in the dashboard. And you are not limited to specifying the complete test result. You can also separate the names with the dots to go and deeper, as deep as you want, or as shallow as you want. For example, CKI only submits this, and ARM could submit these kind of details, but for LCP results. We also provide a field for describing the environment where the tests ran, but at this moment it's very basic, just a human readable description and the same misc field where you can put whatever you want. We still haven't reached the stage of formalizing those. Further on, so subscription system is basically watching what goes through the message queue and then what compares it to what is in the database and decides which objects have changed, like which revision has updated or which build has updated, and then hands it off to Python modules which represent developer subscription. So it is up to developer to decide what they want to see, and we provide the flexibility of Python and the access to data objects to decide when you want a notification. Like you can specify, for example, you want to see all test results for this particular repository or these particular tests, or you want to see, and for example, you want to see test results only after the revision spent, I don't know, a day in testing, or if particular failures occurred, or whatever you want. Basically, we want to keep the door open as much as possible at this stage to aggregate all the requests for features or to figure out what the developers might want to do with this data. Here's an example of a very basic subscription for stable kernel results. And here's a proof of concept report that we send right now to development list. You can see that there is an overview, information about the revision, where it came from, what the commit hash, etc. was. Then we get both the KernelCI builds and the CKI builds in the same spot, and we get that followed by test results from KernelCI and by CKI. This is rather crowded, and there's many more test results there. but let's see a further slide about this. The submission interface is very simple. You can either use a command line tool and just pipe your JSON there. This is an example of submitting an empty report. And another example in Python, which you can also use doing the same thing. Here's an example of the code and KernelCI backend submitting results to KCI-ADB, and it comes in at 265 lines of Python code. Another example is Gento's gKernelCI interface, which comes in at 193 lines, and it's written in Python and Shell using the command line tool. And here's another example of syscaller interface, which is using the third interface, basically talking directly to the Google Cloud PubSub interface. And this file is the interface in itself. There is also a file with the description of KCI-ADB schema, which is not that relevant. And this one comes at still under 200 lines. We also have a submission how-to if you want to do that. And there's some basic description of how you can start. And finally, we have a separate setup called Playground, where you can get access to and just play with your data, try to submit your data either manually or automatically, and see how it comes out on the dashboard and what it takes to get your data to look just like you want it. So this was all about the current release of KCI-ADB v8, and for the next release, which we are working on right now, it's going to come out this spring, hopefully. We are working on renaming the revision objects to checkouts because the ID granularity didn't match the data granularity, basically. I don't want to go into too many details here. So we're adjusting the IDs and renaming the objects. And another thing is that we have logs currently for checkouts and builds and tests as well specified as URLs, and you have to host those logs. The submitting CI system is responsible for hosting those logs for now. But other CI systems like 0-day, they don't host logs. They just send snippets of those logs directly in reports. To accommodate that, we are adding log excerpt fields to directly store the log pieces in the database. This will help us bring them on board, and also, for example, put those log excerpts directly into the email reports and the dashboards right there where you see the results. We are adding another database backend in addition to Google BigQuery. We've also added SQLite to simplify debugging and to provide for some features that require just caching a piece of data there and working with it, like the notification system. And regarding that, we also re-implemented our object relational mapping to make it a little more sophisticated, to represent the data not directly represented by database relations, like extracting the revisions from the checkout data. So there might be multiple checkouts for a single revision. So we are kind of extracting the revision information from that using object relational mapping, and then we use that with the new template system. And here's an example of a report we are working on right now, and it's different from the previous one in that it kind of condenses all the data from various CI systems better. You can see that there is a line specifying where the data came from for this revision. There's the 4 submitters for this one. And we condensed the builds, of course, in a smaller table. It would look pretty bad if we just put all 858 builds of this revision here on the report. And then the builds, of course, these counters are not actual, executions for tests, but unique, test names. And there might be more executions for, like, more than one execution for each test. Further on, after this release, we of course would like to get more features done. One of them is somehow accommodating regression detection and known issues, so that we don't have to bother the developers with issues that are registered somewhere in a bug tracker or somebody is working already on. That's particularly important for Sysbot who have the known issue detection, but they don't use it with KCIDB. They only submit the known issues. Not known, but the new issues, not the old ones. Only failures go into our database right now. And we would like to support the issue detection natively and to avoid bothering the developers, as I said. So we would like to have additional incident and issue objects which can refer to a test issue or to a build issue. Another one is support for linters, of course, and 0 day might need that. And then we need to correlate the test results between similar hardware, so you could see where which hardware an issue reproduces and which it doesn't, and all these good things. We don't have a very good idea for how to do that right now. Perhaps, you know, just formalize all the possible hardware parameters, or just take whatever comes in and let the users figure it out, you know, by hand in the dashboard. That's the two main ideas right now. Bisections and benchmarks is, of course, more features that we want to do. So if you want to help, here are our main repos on GitHub. We have a bunch of much more than on the screen right now, bunch of good first issues where you can start if you want to help. And of course, we have a mail list. You can send us messages directly or subscribe. And finally, of course, we have the IRC channel KernelCI on freenode.net. That's all. Thank you.